Hello, my name is Drennan Kessinger, and I'm going to talk about data analytics. So, before we begin, just a quick definition. Data analytics is the science of examining raw data with the purpose of drawing conclusions about that information. Data analytics is used in many industries to allow companies and organizations to make better business decisions, and in the sciences to verify or disprove existing models or theories. So now that you kind of understand what data analytics is, what do people use it for? As you can see here, this chart shows a couple different things. Forecasting and marketing are two very big ones. Marketing research is a very popular field right now, and then also customer service, product offers, and fraud detection are things that people use data analytics for. So how does it work? Well, here's just kind of a chart I found that I think really illustrates the point. As you can see, the data is collected and then it's processed, and then from there you clean the data, you use exploratory data analysis, you input the data into models or algorithms, and then from there you get the data product, and then or you're able to communicate that data into making decisions. So what is this process? The first step is data collection, clearly. So the data is collected from different sources. Some sources that are popular, online surveys that you may take, customer service surveys, data sensors, such that are just put in random spots at stoplights to see the amount of traffic in the area, and then website traffic reports. How many people are on your site, what products are they viewing, are they viewing multiple products, are they purchasing, etc. The second part is data processing. So this is the organizing of the data, and there are four parts of this. So aggregation, which is adding two different data sets together to form one thing. Sorting, which is looking through the data and making sure you've put it in the right spot. Summarization is getting rid of all the useless data and getting to the main points. And then validation is basically making sure that the data you're using is correct. So the next step we have is data cleaning, and this is where you check for data errors, just to make sure that you don't have any frauds, and you also look for outliers, and you look to see why you have them, and then also you want to remove duplicates. So if you have the same data set twice, it was entered on accident twice, you just go ahead and remove the second one. And then also you want to make sure the data is in the correct spot. So when you're collecting all this data, you might put it in multiple different places. So you want to make sure that you didn't make an error when putting it in the correct spot. The next step is exploratory data analysis. The EDA approach is precisely that, an approach, not a set of techniques, but an attitude or philosophy about how a data analysis should be carried out. So how I would describe exploratory data analysis is once you have all this data and you've processed it and looked at it further, you now want to think, okay, how do we want to use this data, and what do we want to use it for? And this is where this EDA step comes in. This is where you make the decision how to move forward with the actual processed data. So now, after the EDA, now you model the data. So this is the structure, the data used in the system. So basically, this is how you set up the data and then use it to your advantage. There are a couple different types of models: conceptual, logical, or physical models. And essentially what the model does is it allows the data to become manageable and useful. So in data analytics, there's two approaches. There's the reactive approach and the proactive approach. And the reactive approach is the approach where you react to a problem or an issue and use data for that. Proactive is just how it sounds. You begin searching for trends, you want to get ahead of the game, you want to make things better, you use a proactive approach. So this is just an infographic that companies use when trying to explain their proactive approach. So data mining, I'm sure you've all heard this. Data mining is a proactive approach. Definitionally, it is the computational process of discovering patterns in large data sets involving methods at the intersection of artificial intelligence, machine learning, statistics, and database systems. So as you can see in the problem, or in the picture at the bottom, you see the steps to it. And what data mining is essentially taking large bulks of data, sifting through it, using programs, using techniques, and trying to find trends within that data so you can make better decisions in the future. So the other approach, reactive, is drawn out here. So as you can see, it starts in the bottom left-hand corner with standard reports, and that basically tells you what happened, what is going on. And then from there, you look at ad hoc reports, queries, and alerts, and this tells you what the problem is, where it is, and how do you fix it. And those four things deal with reporting the problem and reporting all the details about it. The next four steps, statistical analysis, forecasting, predictive modeling, and optimization, are the analytics side of it. This is what you want to do when you want to answer the questions, why is this happening? What if these trends continue? What will happen next? And what's the best thing that we can do? And by following these 8 steps, you will be able to solve any problem. So what could cause potentially bad or ineffective analytics? Well, bad sample sizes is a common one. If you either have too little of a sample size from your data or too much, your data could be skewed. False positives, meaning you get data that is incorrect. And then finally, too much data. You bite off more than you can chew, and your system gets overloaded and it's saturated, and you can't do anything now with the data. It's just too large for you to process. And so you either have to spend money and time dealing with it, or you just have to leave the data alone completely. So what are programs that companies will use for data analytics? The four ones I did research on are Tableau Public, OpenRefine, RapidMiner, and Google Fusion Tables. And these are just software programs that help companies carry out data analytics. So what are some companies to go for data analytics? Well, 5 I looked at were PricewaterhouseCoopers, Accenture, Oracle, SAP, and Deloitte. And all these companies have departments, and they consult companies and help companies with data analytics to help them solve problems. So at the end of the day, we want to know why is this important? Well, 3 things. 1, it will allow companies to identify problems. If a company is struggling with their market share, or if consumers aren't buying their products, it allows them to go in and find the reason why. It also allows companies to be more efficient. By looking at the data that the company itself produces, they can go in and look at their systems and their operations, and they can find areas where they can be more efficient and reduce waste and reduce costs. And then finally, it just allows you to make better decisions because there's a large amount of information at your fingertips. Excuse me. And what it does is it allows you to make better choices for the company because you'll be more informed and you'll be able to see the trends and see where you want to make changes. Thank you for listening, and here are my sources.